This is the second lesson on the SAT Math Substitution Strategy. And to review it briefly, what you want to do in problems with have variables in the question and answer, choose numbers for the variables that meet the conditions of the problem, then solve the problem as an arithmetic problem, then use those numbers to check the answer choices until you get a match with your solution. As usual, if you want to try this on your own before looking at the solution, you can pause the screen now. If v, w, x, y, and z are positive integers and 5v is equal to 3w, which is equal to 6x, which is equal to 2y, which is equal to 12z, which of the following is the largest? Okay, so let's choose some numbers here. So we want to try to avoid choosing numbers that are in the problem. So let's try 4 for z. So 12z is 48. So 2y also has to be 48. So y has to be 24. And 6x also has to be 48, so x is 8, and so on. So w is 16, and 48, 5 nines are 45, and then 0.6. So which is the largest? Remember, you always want to give them exactly what they want. And the largest variable here is y. Next problem. If you want to try this by yourself before looking at the solution, you can pause the screen now. Okay, so what are they asking? How much greater is x plus m than x minus m? So let's choose some numbers. So let's make x 20 and m 3 and n 8. So remember, this minus is part of the operation, but n is a positive 8. So what's the answer to the arithmetic problem? How much greater is 23 than 12? So our answer and our target is 11. Now let's check the answer choices. 2 times x is 40 plus 3 minus 8. Well, that's too high. M minus n. So 3 minus 8. Okay, so that doesn't work. M plus n. Well, m plus n is 3 plus 8, so that's our answer. Okay, and the algebraic solution is x plus m minus the entire quantity x minus n. So we have x plus m minus x, a minus of a minus is a plus. So positive x and negative x cancel out, so we end up with m plus n. Next problem. Okay, as usual, you could pause the screen to try it on your own before looking at the solution. Here, x is equal to 8 times y to the 4th over 2 to the z. What happens to x when y and z are doubled? So we need a y and a z. Let's make y3 and z5. So first we have to know what it is initially. So 8 times 3 to the 4th over 2 times 5. 3 squared is 9, so 9 times another 9 is 81. So we have 8 times 81 over 10, and that's going to give us 64.8. Okay, and now when we double them. So y becomes 6, so it becomes 8 times 6 to the 4th over 2 times 10. Okay, which is equal to 8 times 1296 over 20, which is equal to, if you divide 20 into that, you get 8 times 64.8. So it becomes 8 times larger. You could have multiplied this out and then divided it by that to have gotten 8 also. What would be the algebraic solution? Well, we'd have 8 times 2y to the 4th over 2 times 2 with z doubled. Okay, so that's 8 times 2 to the 4th. 2 2s are 4 times 4 is 16. So we have 16 y to the 4th over, well, let's just keep this as 2 times 2 times z. Okay, but we want to express it in terms of the original x, which is 8 y to the 4th over 2z. So we have the 8 2y to the 4th and z. So the difference between the doubled expression and the original one is 16 over 2, or 8 times the original value of x. Let's try one more problem. You can pause the screen if you want to try this on your own. So here, if x is equal to 3r and r is equal to 6y and y is equal to z over 2, what is x in terms of z? Okay, so in terms of problems, so we can cross that out. The arithmetic question becomes what is x, and we choose a number for z. Okay, so let's say if we make z 18, so y is 18 over 2, or 9, r is 6 times y, which is 54, and x is 3 times 54, or 162. Okay, so that's our targets. So obviously x isn't equal to z. And if z is 18, 4 times that, 4.5 times that isn't going to make that, because like 5 times 20 isn't high enough, so 4.5 times 18 won't be. So 9 times z, so 18 times 9. 72, 9 is 109. Okay, so that's the answer. Okay, and algebraically, x is equal to 3 times r, and r is equal to 6 times y, and y is equal to z over 2. So 3 times 6 is 18. 18 divided by 2 is 9. Okay. So that's the end of our second session on the substitution strategy.